Hi everyone, welcome to today's session. Today we'll be working through together how you can use network automation to deploy OSPF networking protocol across multiple routers. If you can remember, the last session we mentioned what Jinja2 templates can be used for. And a practical example today is taking it a step ahead and the ability to use the Jinja2 templates coupled with the Netmiko module for networking to be able to provision OSPF, which is one of the most common routing protocol across the networking industry. So let's follow together. I have my lab here. So this is a typical example of an MPLS backbone network. So we have the two provider edge, PE1 and PE2. We also have the provider router as well. So which the three of them forms the MPLS backbone. And ordinarily, an underlying protocol needs to be running between them, which is some engineers use ISIs, while some use OSPF. But in this session, we'll be using OSPF across the three routers. So now, why are we using network automation? In a situation whereby you are scaling, maybe you want to configure it across multiple routers, more than 3, 4, 5, 6. So instead of trying to SSH or logging into each of the box one after the other, you can actually do this in a simpler way using the templating and the Netmiko module using Python. So I have the host IP here, which is 29.130, 131 for R3, and 132 for R4. And as well, I have the connecting network, that's the physical subnet that connects from the PE1 to the P, which is the 192.168.23. And as well, on the other side, I have the 192.168.34.0. So these IPs are actually the physical subnets, the connecting IP. So the objective of this lab is to actually configure the loopback IP address on each of the routers. That's the first point. So the second point is actually to deploy OSPF across the routers without even logging into the routers at all. And the third part is to validate what we've configured at the end of the day. Okay, is our OSPF label up, and can then learn. So the ability is for each of these PE to be able to learn each of those routers look back IP address, and for the OSPF state to go to the full state at the end of the day. So that's our objective. So let's go on together. So I have my VS Code, which I use for my IDE environment. So this is my CSV. So the CSV contains what I actually need for this deployment. I need the host, which is the host IP, to be able to reach those devices. I have the lookback. These are CSV. You can have it in an Excel, save it in a CSV format and put it here. And I have the physical subnet. The physical subnet are the network that connects the PE1 to the P router, which is the provider router, from the PE2 to the provider router. So you can notice that on the PE2, which is the line that I itemized, that it has two physical subnets. So the one that connected to the router 2 and router 3, and the one that connects the router 3 and router 4. That's connecting to PE1 and PE2. That's why we have two subnets. And you notice that I use a column to separate them. So I have a reason for using this. So this is how your CSV, your inventory file, is going to look like. And I have my template. This is what actually we want to do, right? We want to configure a loopback, interface loopback 0, description, and also put in the IP address there. This is awesome. And also we have, and you can see this loopback IP is a variable, right? So it's going to pick it up from this variable here, loopback underscore IP. If you don't understand Jinja2 template, kindly go back to my previous session, my previous video, to look at it once again. So this is this loopback IP. It takes it up from the CSV file. Same thing. So this is the router OSPF. I want to configure the OSPF the usual way we do it as a network engineer. The router ID, which is the loopback IP address. Then I'm advertising the loopback first. Then There's a condition here. I'm putting a conditional loop. For subnet in physical subnet, advertise each of the network and putting it an area 0. So what it's typically doing here is it's looking at, okay, this physical subnet. So assuming we have more than one physical subnet, you should iterate through it, then advertise each of them. So for example, if you have only one physical subnet, just advertise this one alone. But in a situation on R3 that we have two physical subnets, it's going to iterate for the first one, configure it, second one, also configure it as well. So that's the beauty of using a Jinja2 template. So this is actually what we want to configure in a nutshell. So let's go to our Python file. So let's walk through the code together. So I'm importing CSV because that's why I have my inventory file. GetPass is actually a module in which you can use to secure your password so that anybody cannot see your password if you want to type it. So it's going to be giving a kind of an interactive session to put your username and your password. Same thing as well, our usual Netmiko module, that's what we use to connect to our network device. The Jinja2 templates, I will have to import it as well. So this is a prompt for me. I'm interacting my username as a variable, right? And my password, but you won't see it. So the get pass is going to ensure that you are echoing the password on the terminal. So I'll be typing, but you won't be able to see what you are typing. So users cannot see your password. So the first part is to open our Jinja2 template, which is what I'm actually doing, which is using the with open handler, the config template Jinja2 as F. So this, I named the template, when I'm opening it, I named it as OSPF template. So that's my whole Jinja2 template. So the next thing is I'm going to now render it. But before rendering it, now I created a function here. So what this function is actually I want to open my CSV file. So that's where I'm bringing in my inventory file. That's the CSV file I'm using. So for role in reader, means that the interesting, if you don't understand how to interact with CSV, you can also check my previous video on how to work with CSV in Python. So if you can check here, for role in reader, so for each of these guys, so it's looking like each of these guys is a key value pair. So the key is more like a dictionary. The key is the host, while the values are the IP under it. The key is the loopback, while the values are the values of the loopback. So the key is a physical subnet. So for each of the row, if you want to iterate through this host, or if you want to iterate through them, you can iterate them, then call them via the name of the key. So if, for example, if you want to get the IP address, this particular IP address, you can say roll into bracket, the square bracket of hosts. So the role is just like an item, just like a for loop. So this guy here is just like a for loop. So what he's actually trying to say is that go to the physical subnet, the dictionary for the physical subnet, then split it with this column. If you can remember the column I put there. And the column is for me to be able to identify the physical subnet. So it's going to split it, then put it as a list. That's why we call it a subnet list. After a subnet list, then I'm rendering it to my templates. So I'm feeding back those values. This subnet list, you can see that I use it in this physical subnet here. So I'm feeding it back to my Jinja2 templates, which is loopback IP and physical subnet. If you come to my Jinja2 template, I have loopback IP and physical subnet. So for subnet in physical subnet, network. So for the physical subnet is a list. So this for loop, I trade through the physical subnet, then put it one after the other, then advertise it as area 0. Then after that, after I've rendered my configuration, that's my configuration template. So everything is now generated on config underscore text, right? So the next thing is to bring up my Netmiko command, the connect handler. So first of all, I need to put the parameters. So and you can see the way I call the host as well. So we are still under the for loop of the for role in header. So we are iterating through the CSV file. So that's why we are calling each of the IP using the role, the square brackets of the host. So the username and the password, the device type is Cisco iOS. Then I'm using the connect handler. This is the keyword argument to say, okay, take all the arguments here and pass it into the connect handler function. So net connect, and so this is pushing the OSPF command to the router. Just is like a print statement, preview configuration. So at the end of the day, our configuration wants to put, we are going to see it. I just printed it lines by line so that we'll be able to see it. Then send it. This is the command to send the configuration to the routers. And at the end of the day, print a statement that, okay, this particular router has been configured for OSPF. So this is an exception in case anything goes wrong. Just to raise it, okay, this is an exception, an error. And it's a very, very important factor in network programming, in Python programming. So, and the last thing is that I use an initiator to, okay, I want to initiate my function after this main function. So I just want to give my code a structure. So if you are working very well with Python, that's why I'm introducing all these concepts so that you can actually have the idea of working with a well-structured Python code. So that's why. So it's initialize it and call this function, which is deploy OSPF. So let me save it. If I save it and say Python, let me cd multiple explanation. So Python deploy OSPF. So the first thing is going to ask for my username. I'm putting it there. The password. I'm putting the password there. So you can see the configuration after the other. Preview configuration below. You can actually see preview configuration, interface loopback 0. This is for the first router. It's going to configure the loopback, configure the after then. This is the configuration for the first router. This is it for the second router, pushing OSPF to a second router. And this is for the third router. So everything has been done. So if you want to do it for 100 devices, this is how simple you'll be able to do it. So interesting stuff. So let's come to the routers here. I have my routers here. So show IP interface brief. You can see that the loopback is there already. From the logs here, you can actually even see that, okay, the configuration that was just done now, this is the logs that's showing here, right here. So now, so another thing is show IP OSPF. So you can see the OSPF is formed, and also is in the full state as well. So interesting. So the all configuration is there. So let me see. Can I ping so show IP routes? Let's say 4.4.4. And I like the loopback. You can see I'm learning the loopback via OSPF. So let me see the last one, 5.5.5. I think 4.2.2.2. Yeah, 3.3. 2.2.2. Let me see if I can learn 2.2.2. I'm also learning it via OSPF. So everything is being learned, and the last time ago was 1 minute ago. So another interesting part is I can actually use my interesting MCP to be able to check. Okay, it's learning it. So okay, let's try to check. What routes can you learn via OSPF? SPF. So if you don't actually understand this MCP, I've done some videos on my channel which I explain this particular MCP are connected to it. So it's going to log into the device and it's going to be able to check. So let me check. Let me check the connectors here. Okay, so show your routing table on the router. So as you can see, it's trying to log into the router. So you can see it's able to learn 2.2.2. So this is the connected route. You can see this is from the router 2. And via OSPF is able to learn 3.3.3, 4.3.3, and 34 dot something. 34, that's it. This one is the connection. This is the pod IP in the remote segment. So it's able to learn all this via OSPF. So this is one of the beauty of AI. So I'm logging into the router. Now I actually can see what's the state of the OSPF process. So you can actually